Hey everybody, this is Larry. This is me going over Q3 of the um, bi-weekly contest 45. Even though this is a Q3, note that this is only a 4-pointer. I actually didn't notice this during the contest, so I had some doubts about my solution just because I thought it was a little bit easy for Q3, so it's a little bit weird. But anyway, that said, hit the like button, hit the subscribe button, join me on Discord. I think this is just a little bit of a reading comprehension problem, and I mean that in the most sincere way. I just don't understand what this problem is asking, so I might have a blind spot on this problem with respect to kind of explanation. So definitely ask your questions about this problem because I was able to jump to this directly, and if you look at my self time, I spent only 2 minutes and a little bit more on this problem, and some of that was just me doubting and just reading this problem. But yeah, for this problem, I guess the core part about this problem is greedy and data structure. And the thing to note is that I don't even know why it has to be A, B, and C. I don't think that comes into play that much. Maybe I'm missing a easier, obvious solution or a harder solution. But basically, the idea is greedy, because when you pick a prefix and a suffix and they have to be the same character, it doesn't make sense to not choose the entire character. And so if you or the entire prefix or suffix where they're always the same characters, right? So that's the greedy component. And from that's pretty much it. So it's just data structure. Maybe data structure you could call it that. You can also just have pointers, to be honest, which I'll go over in a second. Don't worry. But yeah, so the greedy observation is that you always choose the maximal prefix and the maximal suffix, and then you remove them, and then you keep on doing it, because 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 there's no decision, right? That's the kind of the logic. I know it's not a mathematical proof, but that's the logic that I go by. Because when you have a C and you have say this is not a great example, but okay. Like you have AA and an A. You always want to choose both A's in a greedy kind of way, right? It doesn't make sense to only take one A because then it can only be worse because then you have an A left over. So that's kind of my logic, and that's basically the solution that I did. This is not optimal space solution, but this is what I did during the contest, and I did it during the 2.5 minutes. But if you have time, you definitely can do better than this. But for me, I kind of didn't want to think, and also I try to implement things in a way such that if I misread the problem or if I had to make changes, in theory I could change the logic easier. I don't know if that was the case here, but why I go with that is that so I use a deck, and this is not necessary, but I use a deck. I convert it to the string to a deck, and then here, as long as the string or the deck representing the string is greater than 1, because if there's only exactly one character, we cannot remove it actually. So it has to have at least 2 characters, and if the first character is equal to the last character, we just basically greedily remove from the prefix and the suffix, and this is kind of, I hope, self-explanatory, even for non-Python users, which is that we remove it from the beginning, as much as we can while it's equal to this current character, and then we remove it from the end while this is equal to the character, and then we return the length afterwards. So yeah, so that's greedy. What's the space-time complexity? It's going to be linear time, linear space, the way that I wrote it, because, well, the deck just has linear space, and because we pop off the left once and pop off the most, so each character gets popped at most once, so that makes it linear time. That said, there is actually a constant space complexity for this. Basically, the idea is that you just have left is equal to 0, right is equal to n minus 1, n is equal to length of s. And so basically, instead of using a deck which has an implicit 2 pointers, you have a left and a right that has 2 pointers, and then now it becomes something similar to this. Maybe it's off by 1. Yeah, maybe this is off by 1, but this is going to be roughly the idea here. something like this. This might not be right, to be honest. Or this, like I said, this may be off by 1, but that's the idea that I would play around with. I don't know why I worded it that way. Again, this may be off by 1, so you might have to kind of play around with this, but because I think this does not return the right answer if this is 0 or something like that, because right is equal to left, and I don't really handle that case. So this is not right, but that's why during the contest I did it during a deck. But this is the general idea, so definitely fix. Maybe if you're just here for the code, and hope you hear this part, which is that you should fix it at home. Yeah, maybe it's something like this. I don't know. Let's give it a quick spin. Oh, I don't define D, because now this is S. Cool. Again, this is probably close to right. There may be an off by 1, but that's how I would do it. And this, of course, is O of 1 space, because you just have left right pointers and some extra variables, and then you just go for the string. And of course, it's still linear time, because so this statement can only be true once for each character, and this statement can only be true once for each character, and then mutually exclusive, stuff like that. So yeah, linear time, constant space, and that's what I have for this problem. You could watch me solve it live during the contest next. Non-empty. Only A, B, and C. I don't get it. Why don't we just be greedy? Hey, thanks for checking out the video. Let me know what you think about this problem, anything at all. Hope you had a great contest. And as I always say, stay safe, stay healthy. To good mental health, and take care of yourself. I'll see you next problem. Bye bye.